Hi, welcome to today's video. We're going to be learning about exponent rules. So there's 8 main rules with exponents, right? So let's dive straight into it. Now, for those who don't know, like an exponent is when you raise something to a power, right? So let's say if I have 2 squared, right? That means 2 times 2, which is 4. So similarly, if I have 3 to the 4th power, that would be 3 times 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So 3 to the 4 becomes 81. As you can see, even a small exponent can get you a big number. So this is just for generic rules, right? So this is what we call the base. Okay, so let's just pretend instead of 2 or 3, we're just going to call it x, right? And then this power could be 2. So this would just be x times x equals x squared. That's how it works. So with the product rule, right? The product rule is like this. Let's say if you have something like x squared times x to the 4th. What you then want to do, you want to add the exponents. So in this case, it would be x 2 plus 4. 2 plus 4 is 6. So the final answer would be x to the 6th. Okay, so that's the product rule. Now, the product rule can only work if both of these bases are the same. Okay, in case we had x squared times y to the 4th, there's nothing you can do. These are 2 different bases. You cannot do anything. The final answer would just be x squared y to the 4th. And that's it. You would just leave it like that. Next one is the quotient rule. The quotient rule is with division. Now, same example. X to the 4th, let's say, over x squared. Okay, so now this is the same thing as x to the 4th divided by x squared. And in this case, what you want to do, you want to subtract fractions. So the numerator, the one on the top, minus the one in the bottom. So 4 divided by 2 is x 4 minus 2. And 4 minus 2 is 2. This would be x squared. That's how that works. Next is the power rule. In this case, if I had x to the 4th in parenthesis, and then I had a 2 on the outside, right? This is x to the 4th times x to the 4th. Now 4 plus 4, as we determined here, it would be x 4 plus 4, which is x to the 8th. Now, because it's repeated addition, right? A much easier way to do this is just to multiply. So instead of doing this the long way, just do x 4 times 2. And 4 times 2 is 8. That's x to the 8th. So the next rule, the 4th rule, this is the power of product rule. Okay? And the power of product is, what if I have 2 different exponents? This would be, let's say I have, let's use this example. So x to the 2, y to the 4th, and I was to square that, right? This exponent distributes into each of these. So this would be x 2 squared times y to the 4th squared. And as we determined from the power rule, we just multiply these. So x 2 times 2, and then y 4 times 2. So 2 times 2 is 4. We get x to the 4th. And then 4 times 2 is 8. Y to the 8th. And then that's how we do the power of product rule. Next one, we do the power of fraction rule. So in this case, let's say we had another fraction, right? We'll change it up a little bit. We'll do the same example here. Let's say we had x squared over y to the fourth, and I wanted to square this. Okay, in this case, the exponent gets distributed. So this is essentially, think about it like this. It's x squared over y to the fourth times x squared over y to the fourth. Okay, so just like when you multiply fractions, you're multiplying the numerators, you're multiplying the denominators. Okay, and as we learned from the product rule, we're just adding. So 2 plus 2 is x to the fourth, and 4 plus 4 is y to the eighth. Okay, and that's it. So next one. This is probably the simplest out of all the exponent rules. What happens when I put something to the power of 0? If x to the power of 0, that's just 1. That's it. Okay? So x to the power of 0, it is 1. What if it was y to the power of 0? Well, that's also 1. What if it was x squared, y to the fourth, over z to the sixth, and w to the seventh, put everything in parentheses, all of that to the power of 0? Well, good news, that's just 1. So see, anytime you see 0 as the exponent, it's just 1. You do not have to do anything else. All right, last one, the negative rule. So far we've just gone to positive exponents, right? Let's say we get a negative exponent. What if we have x to the minus 2? What would that look like? So a negative exponent means that you have to flip it. So this would be 1 over x squared. So that's what a negative exponent means. You're flipping it. So if it's x to the negative 1, that's just 1 over x. Okay, so this means you have to take the reciprocal of whatever this is. Let's say we had x to the negative 3. That's 1 over x 3. Okay, and then that's how we solve these problems. And the last rule, this is the fraction rule. So what if we get an exponent that's a fraction? Let's say we get x to the 1/2. X to the 1/2 means this is a half power. This means square root. So this would be the square root of x. Now, if I have x to the 1/3, that means we're taking the cubed root of x. What if I were to have some kind of crazy fraction like x to the 2/3? So this, we employ something called power over root. In this case, we do the same thing. So the root is at the bottom, okay? So if it's 3 at the bottom, we know that this is a cubed root. This 2 at the top means that the x on the inside has a power of 2. So that's how that works. Now, to show you another example, let's say we had x to the 5/6. This becomes 6, and then on the inside, it's x to the 5. Right? And then that's how it is. So now you know all the exponent rules, okay? So you can get excited for that. Bye.